Welcome to the Stormsurf video surf forecast for the week starting Sunday, July 1st. Looking at significant wave heights for the South Pacific Ocean, again we see a rather calm pattern. A small gale is generating 24-foot seas over a small patch in the deep South Central Pacific, but that's really not enough to make any significant energy to reach up into Hawaii and California. The good news is the pattern is to change slightly in the more favorable direction. We'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. We're looking for a trough, and there is one. It's a very weak one, though, right here in the deep Central South Pacific. That's what's helping support some sort of gale development here. But notice winds pushing to the north are only, 80 knots? Not very much. You want at least 110 knots and preferably more pushing to the north. That helps set up a clockwise circulation. Remember, low pressure in the southern hemisphere rotates clockwise, counterclockwise in the northern hemisphere. And so that's in the upper levels of the atmosphere, but also sort of helps set up a circulation down at the surface. And of course, surface low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, creates surf. So we're going to keep looking for troughs and not ridges like here. A ridge to the south helps create a counterclockwise flow aloft, and that's the sign of high pressure. So we have a ridge here, sort of a ridge here, and a weak trough right now. Let's see what the forecast suggests. A little bit more energies to push in from the west starting, about midday Monday. What's that? That is now 120 knot winds. Not too bad. Kind of fading, but sets up another trough, maybe, and sort of in the same area. Maybe supportive of a little bit stronger gale development. Then it too fades as it pushes east into Tuesday and Wednesday. Then another trough tries to organize here. What's that? With 110 knot winds, but pretty far to the south. The ice line's somewhere right around 64, 63, something like that in spots. And that trough just barely sneaks north of the ice line. You want it to be a little bit clearer further north than that, and the trough kind of fades out. So, and also notice here's the northern jet stream, pretty much running east on the 32, 33 degree latitude line, south, but it's really the southern branch that has all the energy to support gale formation. The interesting news here is the southern branch does not look particularly strong, but it's not like it's ridging hard south either. As we get into Saturday. Not really supportive of gale development, but then there is a ridge pushing south as we get into Sunday, and that will pretty much shut down development potential in here. But notice, there's a trough behind it with decent winds. Let's see what happens as we get, there we go, as we get 180 hours out. Decent trough under New Zealand, good position for California in the swell window, and for Hawaii, but it's 180 hours out. We never believe a model that far into the future, but it's a step in the right direction. Let's take a look down at the surface. And here we go, surface level pressure, surface level winds. Sure enough, there's a gale, 35, barely 40 knots right now, 18Z Sunday. That's associated with that trough that we saw in the upper atmosphere, and those winds continue as we get into Monday, but still 40 knots. Maybe we'll get something out. We'll take a look at the wave model, see what's happening. A little bit more interest here south of Tasmania. Some sort of a strong, broad gale developing. We continue as we get into Tuesday. Now notice most of the fetch here is pushing southeast. Not good, but there's a solid fetch back just southeast of Tasmania we'll just get it Tuesday morning. There we go. Broad area, 40 knot winds aimed east, almost northeast here. That's good. Let's see if it holds together. Winds build to 45 knots, 18Z on Tuesday, and good out of the southwest direction. And this is an upgrade from previous models. Now to 45 knots as we get into Wednesday. You're seeing it just as we are here too. Now the ice line, remember, is down here, so this little patch of 50 knot fetch is only good for blowing penguins around. As we get into Wednesday, it continues, then it fades out. Also notice a little cutoff gale developing back here. Almost looks tropical in nature, falling southeast. Probably not good for much swell development. Okay, so now here we are into Thursday, almost Friday. Stationary, small area of 40 to 45 knot winds aim north. and in the California swell window, just barely, and hanging as we get into Friday before it dissipates. So we got a couple of systems here. Things are looking marginally better compared to where they were last week. Rolling out again, we're into Sunday a week out. Broad area of low pressure developing, gale low, almost over and south of New Zealand. There we are at 180 hours. Doesn't look very organized. Don't believe it that far out. But again, it's another step in the right direction. So finally, let's see what the effects of those winds are on the ocean surface. Now we know we have a weak little gale here with officially 24.4 foot seas in its apex and its highest spot, continuing into Monday and starting to push out of the almost out of the California swell window, while a much stronger system starts developing south of Tasmania. Not in the swell window just yet. Now notice almost 28 foot seas. You know, this might be good for a little pulse of 14-second period swell pushing up into Southern California or so about a week out. But the issue is you really need a 16-second period or more, which means you really need 30-foot seas. And it's at that 16-second period interval that swells can travel much further without having a whole lot of decay. So our focus then turns to the system south of New Zealand. We see, there we go, nice area of, about 36, 37-foot seas. Let's see, 30, 32, 34, 36. Yeah, we'll say 37-foot seas. So we get into Tuesday in the swell window up to 38, 39 feet, continuing into Tuesday night, pushing east into Wednesday. Now, most of this energy looks to be pushing off to the east, but the great circle tracks relative to California right in here or something like that. So some of this energy could radiate north, not as much. It'd be much better if this fetch and the energy travel was more to the northeast, but sideband energy seems likely. Most of this energy likely heading for Central America. And it fades out as we get into Thursday. Remember, a little tiny system here, almost like a extratropical sort of system on the edge of the California swell window, 32 to maybe, 34-foot seas, and then moving out of the swell window, maybe some dribbles from that. And then we're into next weekend already. Nothing immediately obvious, and again, it's a week out. Now, this system is blocked by New Zealand relative to Hawaii, relative to the U.S. West Coast, somewhat in the Fiji swell window. If you go back more here, it was actually much stronger yesterday and the day before on the models. Oops, and that's the end of it. So we don't know whether this will survive, whether it'll even form at all, much less make it east of New Zealand and get cleanly into the Hawaii and California swell window. But it looks like at least there's some hope on the charts. Then let's take a look at wind swell potential. Remnants of a tropical system here, south, doing nothing. Nothing expected from it. Did not generate any swell. I don't believe it barely got into the tropical storm strength category, and that was it. So, high pressure, 1032 millibars in the Gulf of Alaska, creating the usual pressure gradient along northern California. Not so much heat inland now as there was a day or two ago, but still tightening up the isobars a little bit, generating 25, almost 30 knot north winds, generating some wind swell into northern California, but we're talking chest high kind of thing, nothing very significant at all. Eddy flow, that's south winds, so there's like low pressure here. You get north winds, and then you get the return flow up the east side of the heat low, and that creates south winds. There was pretty good south winds in northern California today. Anyway, tomorrow, winds pick up, you see, as we get into Monday morning, 30, 35 knots. That should bump the wind swell up a little bit. It exposed breaks in north and central California. And that continues into Tuesday. Also notice, we'll scroll down here, large tropical system forecast on the charts. It's developing now. We'll get into that in a minute. Back to here. All right. And wind swell starts dying out as we get into Tuesday night and Wednesday. Notice trades building. Let's go back. Let's take a look at Hawaii here. So while this wind swell was building relative to Northern California on Monday, notice fetch off the south side of the high, also starting to push towards Hawaii, 15 knots, getting pretty solid there about midday Monday. Maybe some wind swell starting to kick up, and the area of the 20-knot winds pushing to within, about maybe 400 nautical miles of Hawaii on Monday night into Tuesday morning. Probably pretty decent sized wind swell along exposed east-facing shores at that point in time. Now we're into Wednesday. The fetch starts fading. Certainly for California, you notice this little low-pressure system develops off the coast here. Cuts the legs out of the high. The gradient fades. We also see, here we can go down a little bit, watch the tropical system as well, see what it's projected to do. So fetch continuing for Hawaii. This system traveling, what is that, northwest almost, pretty solid. Certainly possible to generate swell up into California. Also maybe sideband swell into Hawaii. We're at Thursday here. We'll pull this up a little bit so you can see the dates now. There we go. And get the general sense, lots of wind swell for Hawaii and some tropical swell for California. This all starts fading out, the tropical system moves over cooler water. High pressure starts ridging in, barely, a long ways away. It's out even a little bit west of Hawaii, trying to ridge east. And we'll just roll this into Saturday, Sunday. Wind swell starts building again relative to California, but all the fetch is right over North and Central California. Pretty jumbled mess would be the expectation. We're into Sunday now, more of the same. So this sort of thing creates upwelling. The south winds creates downwelling, warms up water temperatures. North winds creates upwelling, bringing cool water to the surface. And there we are at 180 hours out. So pretty much a fair amount of wind swell for California, not necessarily great conditions. More wind swell, it almost looks like, for Hawaii, and some potential for tropical swell for both. Here you go. This is tropical storm Fabio, now with 55-knot winds, tracking west-northwest, right there. Forecast, you can see it building up to 115-knot winds. That's 132 miles per hour on 318 right there. So that'd be pretty much south of, not quite Los Angeles, Point Dume area, probably best exposed. Some tropical swell from that. The better path would be if it were moving more north. This sort of west-northwest track sends most of the energy moving in the direction of travel, and Hawaii's off over here somewhere, but much further away. So kind of threading the needle both between Hawaii and California, not favoring either one in terms of support for swell development. But for that matter, we'll say a little bit of swell is possible. Exposed breaks in Southern California. You have to monitor it. Never trust these models more than about 24 hours out on a tropical system. Anyway, as you get to the 4th of July, things start fading out, the storm starts fading, and that's the end of it. So that's it for this week's forecast. Let's take a look longer term out. What's going to go on in the next month or 2 or 3? Is there better potential for swell development? And of course the answer is we think so. If you've been following this, you know exactly why, but we'll go through the drill again so that everyone can share in the glory of what we think is coming. And of course, we'll start off trying to look at the Madden-Julian oscillation. What's that? Well, it's a periodic weather oscillation, a pattern basically, that travels. So this is the West Pacific here. This is the East Pacific here. We're on the equator. It moves from west to east. Typically, about every 4 weeks, like the active phase will make its way. It goes the whole way across the Pacific on the equator. It actually goes the whole way around the world. Okay, first in the active phase, and then 4 weeks later, the inactive phase, and then back to the active phase. And it just sort of pulses on this monthly, but it can vary anywhere from 3 to 6 weeks. It really depends. In the active state, what it does is suppresses trade winds in the West Pacific, and that's actually a good thing. It creates more cloudiness. It pushes energy into the upper atmosphere. That feeds the jet stream, especially in winter months. That really gooses up the jet stream. And as you kind of gathered from looking at the charts, a stronger jet stream means a stronger storm pattern. And so if you have 3 weeks of enhanced active MJO activity here in the West Pacific. Then you have 3 weeks of enhanced activity in the jet stream. And so if you really are a close follower of all this, you'll see you get cycles of storms. So it goes on for 3 weeks, off for 3 weeks, or on for 4 or 5 weeks and off for 4 or 5 weeks. And that's all tied to the MJO. Now that's in the northern hemisphere in winter months. Southern hemisphere in winter months, the correlation isn't as tight. But still, it does have, the active phase of the MJO, so it does have some positive correlation to feeding the jet stream in the southern hemisphere. All right, so first off, what we're looking for, actual wind speeds. This is from the TAO buoy array, a series of buoys strung across the equator. You look at the arrows, not the numbers. That's water temperature. We don't care about that at the moment. But what we see is strong easterly winds across the eastern part of the Pacific. Galapagos are like right off here, and there's New Guinea there. And those easterly winds fading a bit, but still easterly over the West Pacific. But it's not so much the actual wind speeds, it's the anomalies, differences from normal from this time of year. You see basically, a little bit stronger. These east arrows mean it's a little bit stronger than normal right here from the east. But then you get over in the West Pacific and you go, if anything, maybe there's a slight westerly component, and it's pretty much normal. So this is, if there were a bunch of west arrows just 5 degrees north and south of the equator, and it's what we call the Kelvin wave generation area, from 170 west to about 135 east. Right in here is the key area. When you get westerly anomalies in here, that starts taking warm water. You see 30-degree temperatures right there, and starts pushing it east, but not on the surface, at depth. It creates a big underwater ball of warm water. It's called a Kelvin wave. It travels the whole way across the Pacific and then erupts, if it's strong enough, over near the Galapagos, boils up to the surface, creates a slick of warm water. If you get a couple of Kelvin waves in a row, that can be the sign of El Nino. And if you've been following this, you know we think we're monitoring the development of a possible El Nino. So we are intently watching for another burst of the active phase of the MJO. There's a Kelvin wave that is in flight. It's erupting right now. We'll get into the details in a second. But what we really want to see is a second Kelvin wave that will reinforce the warm water pattern that's already starting to develop in the East Pacific over here. You can see it. 0.5 degree anomalies right in this area, maybe 1 degree anomalies right here. Last year at this time, it was all cold, negative temperature anomalies here. That's the sign of La Nina. La Nina definitely suppresses storm development, both in the winter and in the summer in the Pacific. La Nina does real good for the southern Atlantic and Indian Oceans. The year before, it was all focused on the Indian Ocean. This year, it's focused on the South Atlantic. South Africa has been going off. Anyway, we digress. So looking for signs of the active phase of the MJO. Let's move on. Let's see what's going on. A Kelvin wave generation here. There's New Guinea right there. South America, Mexico. So Kelvin wave generation area in a box, a little box right here. Looking for westerly anomalies. That would be these reds and yellows, but they're not really in the Kelvin wave. We see them off east of the date line and over the East Pacific, but not in the West Pacific. And we're just going back June 25th, 26th. You can kind of eyeball it. You see, yeah, there's some westerly anomalies, but not much. So it's kind of a neutral pattern is what it looks like right now. So let's go look at the forecast. Okay, this is the whole planet on one chart. The date line is right down the middle of the chart. So West Pacific is in between these two tick marks, and notice this past history here. We're looking for yellows and reds. Those are westerly anomalies. Blues like this are easterly anomalies, meaning the inactive phase of the MJO, especially if it goes on for a long period of time and you kind of go down here and go, yeah, sure, certainly looks like most of June we've been in the inactive phase of the MJO, and it looks like, here we go, July 1st, that's the day. It's maybe peaking out like right now, and then maybe supposed to be fading as we get a week from now with weak westerly anomalies trying to build, but no real obvious sign of a strong active phase of the MJO, at least a week out. So then we can go look at a 2-week forecast. Outgoing long wave radiation. What's that mean? Cloud cover. More cloudy, less cloudy. Yellows mean positive anomalies, meaning less clouds, more sunlight reflectivity off the ocean surface, meaning high pressure. That means the inactive phase of the MJO. So yeah, we're in the inactive phase right now. Seems pretty obvious. By 5 days out, it's fading. Dead neutral 2 weeks out, but maybe the active phase making a little headway out of the Indian Ocean, not much, this per the statistic model. The dynamic model, basically a mirror image of the same thing. The two models are in sync. That means no active phase for the next 2 weeks, but at least the inactive phase is supposed to fade. Well, if that's the case, where is the active phase of the MJO? If it's not in the Pacific, it's got to be somewhere else. It's always somewhere, right? You just have to know where. So, phase diagram charts. Assume you're looking down on the North Pole. The MJO, active phase, moves from west to east. So does the inactive phase. From the Indian Ocean over the Maritime Continent, across the West Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. So in the Indian Ocean somewhere, maybe the Western Indian Ocean, the green chart, or the green line is where it's supposed to be. If it's inside this circle, it's considered to be extremely weak. What we really want is a strong active phase in the West Pacific, somewhere over here. So according to this, for the next 2 weeks, it's slowly making its way off to the east, and maybe kind of moderate in strength in the far West Pacific 2 weeks from now, this per the ECMF model. But the GEFS model, the dynamic model, says, not so great, not so strong, not as much eastward progress, somewhere over the Maritime Continent, like Bali or somewhere like that. So not even in the Pacific Ocean yet. Okay, that's not encouraging. So let's go even further out. So this is upper level, jet stream level, odds, we say, favorable for precipitation. Yellows are not favorable for precipitation. And there's South America, there's New Guinea, Australia, you get it. The equator is right there. So the yellows suggest, and this runs about a week or two ahead of what's going on down at the surface. So this suggests this yellow inactive phase of the MJO in the equatorial Pacific working its way finally out over the Galapagos, maybe towards the middle, end of July, and then a weak, but apparently modest active phase building in behind, slowly easing east through the 10th of August. So what this really says is not a particularly strong MJO signal at all for the next 40 days. Let's go look even further out. So then we look at the CFS model, 850 millibar wind anomalies. And this is a little bit different. Here's past performance. Oh, and there's the date line right there. Kelvin wave generation area between these two tick marks going up. You see, yeah, here's the westerly anomalies we've had recently. We saw it on the other chart, but they're all kind of east of the Kelvin wave generation area. Now here we are. What's this? 5 days from now? A pretty good pulse of westerly winds forecast. What's driving that? Well, we sort of overlay Rossby waves. What's a Rossby wave? Well, we're not going to get into all the details, but there is a Rossby wave. Kind of moves opposite of the MJO, but it looks like this Rossby wave in the Pacific is to help produce at least a patch of westerly anomalies for a little bit on the date line for a couple of days. That's probably not enough to set up a Kelvin wave. You need something longer than that, so we're just going to ignore that. But it's there. But the interesting part is westerly anomalies continue in the Kelvin wave generation area with no obvious sign of easterly anomalies. These are out at, what's that, about 130 east? So that's outside of the Kelvin wave generation area. That's over the Maritime Continent. So what we're basically, if we can get past the next 2 days, it looks like a westerly anomaly pattern is to start building in the Kelvin wave generation area nonstop. And as we get to August 10th, it's actually supposed to build quite strong. This is actually looking like a westerly wind burst. This could be the sign. What we really want is another Kelvin wave, right? This might be that. It's been on the charts for a long time. It takes a good amount of westerly winds over a long period of time in the Kelvin wave generation area to produce a Kelvin wave. So this is what we're looking for. Let's overlay the MJO now, just so you see what's going on. Okay, dotted contours, inactive phase of the MJO. So we're in the inactive phase. We know that. Even though we get a little westerly wind burst, inactive phase kind of backs off a little bit, resurges a little bit as we get into July, as we get through the month of July. So basically all of July is dominated by the inactive phase of the MJO. But westerly anomalies continue in the Kelvin wave generation area. Weak, but they're there. That's a good sign. Now, here's where things get interesting. As we start to turn to fall, August 8th, let's say, MJO, active phase, builds pretty strong. 1, 2, 3, 4 contours with a westerly wind burst in the middle of it, going from, about the 15th of August to, what's this? Almost the 15th of September, a month of westerly anomalies. If you want to believe this model, I mean, we don't believe it, but it's been on the charts for a long time. This would be very good news. That would certainly generate a Kelvin wave, then followed by the inactive phase, but westerly anomalies continue. Now, what's driving all this? Low-pass filter. We'll put that on there. So this solid contour is what we call an area that's biased towards low pressure. Last year, it was all over in the Indian Ocean, over in here somewhere. It has steadily migrated to the east. Okay, and what this basically says is La Nina is dead. This dotted contour is the high pressure bias. That's what was over the Kelvin wave generation area for the past year and a half or so. It is steadily fading to be completely gone, moving inland over the United States and then dissipating as we get into September, while the low pressure bias builds. So it's up to 3 contours here in the late July, August time frame. But it's interesting. Just about every other run we've seen has that continuing on into the fall and probably beyond that. This is the hallmark of some sign of El Nino developing, and it hasn't wavered on the models at all. So this is good news. All right, so let's go take a look subsurface. What's going on with ocean temperatures? East Pacific here, West Pacific here. Same TAO buoy array strung across the equator, 2 south to 2 north. These are the sensors on the anchor lines of the TAO buoys, and what you get with this, with a little bit of fancy software thrown, is you get to sort of fill in the gaps where there aren't sensors and get a profile of where water temperatures are. This is in centigrade, 30-degree temperatures here in the West Pacific. The key part here is the 28-degree isotherm line. All year, last year, it was like at 180. Strong easterly anomalies blowing, pushing, or basically holding off warm water, balling it up in the West Pacific. But now, trades have slackened in the Kelvin wave generation area. Warm water sloshing east, so it moved to about 155 west a month ago, to 150 west. Now it's to 148, pushing maybe towards 147. So a steady easterly movement of the 28-degree isotherm line. The 24-degree isotherm line, pretty thick right here, up until right before it gets into Ecuador, down to, what is that, 25 meters deep or so, 75 meters deep. So not as deep as it was. Let's go look at anomalies. So differences from normal for this time of year. Okay, so you see 3 degrees centigrade. That's a bunch more than that in Fahrenheit. But we see warm water. This was all cold water last year. Now it's all warm water, and it's pushing. You see, check out this. So where are we? There's the date line right there. Kelvin wave generation area is this area somewhere right along in here. Westerly anomalies blow, push warm water to depth, and look at this. You got a river of warm water flowing into the East Pacific. Here's the core of the current Kelvin wave. This was generated by a strong westerly wind burst in February. It takes 3 to 4 months for a Kelvin wave to make it across the Pacific and start erupting off of Ecuador, okay? So still, good amount of warm water here, not as much as it was. Let's take a look at another modeled version of this. This highlights it a little bit better. Here's the core of the Kelvin wave. What is this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4.5-degree anomalies right here. Where is this? Somewhere south of California, only on the equator now. But you see it erupting in between, what's that, 150 west? That's almost from Hawaii to almost to Ecuador, or at least the Galapagos. That's a broad area of this warm water moving to the surface here, okay? Again, caused by westerly anomalies. Also notice more warm water back here. All we need is a little push of westerly anomalies. That's why we keep looking at the MJO, keep looking for a westerly wind burst. We want to get more warm water pushing this way. The more it builds up on the surface in the East Pacific, the more that feeds the jet stream, and it pushes the focus of where the jet stream's energy is more to the east. It'll push it into like the Gulf of Alaska in the fall and winter months, and that's good for storm production for Hawaii and California. It also is good for pushing rainfall into California. If the core of the warm water is more out back here, it's what they call like a Modoki El Nino. El Nino sort of like an El Nino. But what ends up happening is you don't get the precipitation into California. So this is a better setup. It looks like a normal easterly erupting kind of Kelvin wave. Sea level anomalies, this is from the Jason 2 or Jason 3 satellite. You strip out all the waves, strip out all the wind swell, strip out the tides. What you're looking for is a bump on the ocean surface. We see at 5, almost pushing 10 centimeters here the whole way. That's the date line, that's the equator. There's New Guinea. The whole way from New Guinea into, there's the Galapagos, Ecuador right there. You see it seeping through the islands here too. A steady flow of warm water pushing from west to east due to a decrease in trade winds in this area. So the bump on the ocean surface, we're talking 5 or 10 centimeters, a couple of inches, right? That's not very much, but what that means is warm water is at depth, warm water expands, and that creates a little bulge on the ocean surface. Last year, we had negative anomalies all in here. So this is again, more data confirming warm water is at depth heading towards the main area over here, the eruption area that helps feed the jet stream in the fall and winter months. That's all good and fine, but it's not subsurface water temperatures that affect the jet stream. It has to be surface eruption of warm waters, and of course warm water evaporates, and that's how it gets into the upper atmosphere. It creates storms and precipitation, and that's how the energy gets transferred to the jet stream. So what do we have? Well, here's Peru. We see cooler anomalies, the blue. You can look at the scale here, you get a sense. Cooler, but that's not really where it matters. It's in the official El Nino monitoring region from 120 west, so from right there out to 170, 5 degrees north and south of the equator. So you have the Kelvin wave generation area off to the other side here, the Nino 3.4 region in here, which is the El Nino monitoring region. But you notice, where's all the heat? 100 off to the Galapagos, so that these images sort of overlay. There's 100, there's 100 there, so it's not two lobes, it's basically a continuation of the same one. Anyway, the point being, you still have trades in here, so this warm water is erupting in this area, and then it's going to get carried by the trades over into the Nino 3.4 region, you know, another month or two after it erupts. So was it a 3 to 4 month travel time across the Atlantic, in the form of a Kelvin wave under the ocean surface. Then it erupts. Then it's another 2 months to make it out over into the Nino 3.4 region. And only once it's there does the atmosphere really pick up on it, but then it starts responding pretty quick. So we have one Kelvin wave erupting, it looks like, and doing quite well. This is solid, not off the charts or anything, but doing solid. And at some point, it will start migrating off to the east. So just for fun, let's put things in comparison. January 1st, 2018, the main El Nino monitoring region, 120 west to 170, right in here. And what do you see? A lot of cold water. This is the hallmark of La Nina. Cold water in this area, stomping on the jet stream. What kind of a winter did we have? Not much of a winter. What kind of a spring did we have? Not much. What kind of a summer are we having for southern hemiswells? Couple, but not a whole lot. Now, what does it look like today? Boom. Big change. Look at all that warm water there. Now, here's the remnants of La Nina here. We want to get that further south, decayed out. There's our eruption point. We need this warm water to start migrating off into here. But clearly, we have we're at normal, if not above normal already. This is good news. This will slowly start impacting the jet stream. The thought is, as we get into August, it'll start helping the southern hemisphere. Maybe we'll get a little flurry of late season storms. No guarantee, just a possibility of that. But certainly as we get into the September timeframe, North Pacific, things should wake up. Tropical systems out in this region, well, we see a fair amount of warm water there, and that's what it takes to generate tropical systems. So not only here, I think I've actually read that we're at a record or near record number of early season East Pacific storms already in this year, all attributable to warm water in this area. Notice lots of warm water off in here. The expectation is that at some point the West Pacific will wake up too, and storms will start recurving. So they blow up in this region, they recurve to the northeast, and if you get into the fall, sometimes they supercharge as they move over the date line, and especially fueled by El Nino, you can get good, strong, early season, long period swells from the northwest in California and Hawaii if that sort of situation develops. We don't know that it will, but we're watching for it. So anyway, you get the idea. That's where we were. That's where we are. Things are way better. At minimum, we're going to return to a normal pattern this winter. The idea is probably something a little bit more. Moving quicker now, the 7-day trend, you can see it here. Warming over the Galapagos, another pocket here. Little pockets of cooling, but pretty much kind of a neutral pattern except for scattered warming right along here. The expectation is this will build some, but this is only the 7-day trend. And then here's the overview. Again, we basically saw that, only that was current data. So here we go. You see it one more time. Warm water building where it needs to. All right, so we have warm water buildup on the ocean surface, a rather recent change. What's going on in the atmosphere? So we use the Southern Oscillation Index to get a sense of what's happening. We're looking for long-term trends. Difference in pressure between Darwin, Australia, and Tahiti. Positive numbers suggest the inactive phase of the MJO. Negative numbers, the positive, I said inactive, right? Negative numbers, the active phase of the MJO. Just sort of scanning down here. It's been kind of a mixed bag, positive, negative, kind of a neutral pattern, and that's what we're seeing everywhere else. The MJO is kind of dead for the moment. We want to see something happen. 30-day average, though, take some of the noise out of these numbers, and what are we seeing? Well, we're seeing, look at where it was positive, heading negative. That's a good sign. Even though we don't have the active phase of the MJO, it's still heading negative. This could be some early signs of El Nino developing. The 90-day average really strips all that noise out. We're going back, here's June 2nd. We're at plus 4.74. Where are we now? Steadily going negative, even with no presence of the active phase of the MJO. Clearly, it appears the atmosphere is already responding to whatever is happening over in the Kelvin wave generation area, a definite slackening of trades across the Western Pacific, Kelvin wave eruptions. It's starting to have some impact globally. This is good news. And now, even more importantly, it's in this same area right here, anywhere on the equator, but mainly, let's say 120 west, so that'd be just eyeballing it, roughly in this area right here. You want to see more rainfall than normal to know for sure that warm water is building this area, and when that happens, then you know the jet stream is going to really start responding. So you look at this, it doesn't tell you, but the number, they actually have an index. It's minus 0.13, so this has been sitting down at, it was like minus 1.9 or something like that a year ago, and it has just been hanging incessantly down in the minus 0.7, 0.8, 0.9 range. Today, it is getting so tantalizing close to being normal. It's like, oh, just get to zero. So what this means is a little bit less than normal rainfall in this area, and here's the actual area right here, the difference between the area north of Darwin, Australia, and this broad area in the Pacific. So not as tight as the El Nino monitoring range, which is more like here to here, but you get the idea. It looks like we're going to be at zero or very well close to zero, maybe within the next week or so. Almost every time we look at this, it keeps inching upwards. That's due to warm water warming in this area, of course. As we get more precipitation anomalies here, the jet stream starts waking up, and then the machine is off to the races, and then we're in good shape. So we want to get to zero. We're very close. This is very good news. Sea surface temperature anomalies in the Nino 1.2 region. This is right along Peru and Ecuador and Chile. Not so important. Below negative. We saw that. Below normal. 1.166 degrees below normal. You can see it's kind of been hanging there for a while, but it's the Nino 3.4 region that really matters. Let's dial that up for you. Here we go. Okay, and zoom in a little bit. You see the trend. Trend is very important here. It's been negative down at like almost -1, steadily upward. We got a bit of a positive spike here earlier in June, continuing upward. We're only talking not even a half a degree, 0.47 of a degree today, but the point being, we finally have gotten positive in the sea surface temperature area in Nino 3.4. The expectation is the SPI is going to go positive at some point, and when that happens, then the jet stream starts getting energy, and then we're off to the races. So this is all looking very good. Where are we going from here? The official forecast from the CFS model for the Nino 3.4 region. So where are we? We're July, positive 0.45. I don't remember what it was, but that's about right on track with what is actually happening right now. But look at the forecast. Up, up, up. In October to 1.25 up to 1.5 degrees above normal as we get into the November time frame, and then holding, slowly declining, but still 1 degree above normal even as we get into next spring. This is a clear sign of El Nino. Most of the other models are saying the same thing. Maybe not as hot as this. This model was actually running cold. Now it seems to be running hotter than all the others. Maybe something's going on. We'll see. But all this suggests some sort of a, we'll say, weak to moderate El Nino for this winter, and based on the data we've seen, eastward displaced, not some sort of a Madoki setup. This would be very good news, and, basically, hey, this is where you want to be. Not a bad situation. We were actually hoping for another year or two before this developed, just sort of have 2 years of neutral temperatures before we went to El Nino, because here's the downside, of course. If you have El Nino, year after that, you fall back to La Nina. And what we really wanted is more heat energy to build up in the oceans before it sort of, exploded and did its thing. But we'll take what we can get. We've had a couple of bad years. This would be good. Bring it on. So to wrap it up, not really any significant swell in the water, but there's signs that a gale is supposed to develop south of New Zealand a couple days out. That would give us swell up into Hawaii. A week after that, maybe 9 days later into California. Not a bad deal. And wind swell, copious wind swell for the immediate future, but that is supposed to fade out, maybe amplified by a little hurricane swell. The far better news is warm water eruption in the East Pacific is on track. Kelvin wave erupting. All the indices moving into the right direction, saying La Nina's dead. We're going to be at least neutral or normal as we get into the fall and winter months. We're expecting some increase in jet stream activity as we get into early August, maybe a late season push in the southern hemi, and then certainly setting us up for hopefully an early fall season in the North Pacific. So things moving very well in the right direction. That's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.